This is your class lesson for section 3.4, part 1 of composition of functions. Let's begin with the definition of f of x and g of x. F of x is equal to 3x minus 4, and g of x is equal to 2x squared minus 1. We've been asked to combine these functions. So we're first asked in 1a what f plus g of 0 is. So f plus g of 0 is f of 0 plus g of 0. Now, we're going to go to f, and everywhere there's an x, we're going to put a 0. So we have 3 times 0 is 0 minus 4. So f of 0 is minus 4. Now let's go to g of 0. G of 0 is 2 times 0 minus 1. So that's just equal to a negative 1. So f plus g of 0 is equal to negative 5. Let's go to b. F minus g of 4. That's defined as f of 4 minus g of 4. Now we might have to go to the side and calculate these, but that's okay. So I'm going to let's use that color. I don't know if that's thin enough. Okay, and that's equal to, let's go over for f of 4, and that's 3 times 4 minus 4, which is 12 minus 4, which is equal to 8. So we have 8 minus, and now we're going to have g of 4. And g of 4 is 2 times 4 squared minus 1. And that's going to be 16 times 2, which is 32, minus 1, and that's 31. So it is 8 minus 31, and that's equal to a negative 23. Sorry about the change in color of the pen. Usually I have my pens showing, but I don't see them. Okay, let's now go to, I'll just switch to this color. Let's go to f g of negative 2. That's defined as f of negative 2 times g of negative 2. And so if you plug negative 2 into f of x, you get 3 times negative 2 minus 4, and that's a negative 10. Wish I didn't have to keep going over there. Times g of negative 2. I guess I'll just stay in one color so it's not annoying. And g takes 2 times x squared, and our x is a negative 2 squared, minus 1. So it's 2 times 4 is 8, minus 1 is 7. So we have negative 10 times 7. We end up with a negative 70. I'm just going to keep this color pen. Okay, in D, f over g of 3 is f of 3 divided by g of 3. And let's go over here and find f of 3. I can just do it right in the numerator there. F of 3 is 3 times 3 minus 4. And g of 3 is 2 times 3 squared minus 1. That numerator is 9 minus 4, which is 5. And denominator 18 minus 1 is 17. So we have 5 over 17. So, whoops. I was trying to get, oh, that was an eraser, not a highlighter. Whoops. So, highlighter, whoops, highlighter, highlighter, and highlighter. There we go. Okay, now, what's the difference between number 1 and number 2? In number 1, we are finding composite combinations at values of x. Do you see? 4, 3, 0, negative 2. But look what's happening here. F plus g of x. f minus g of x, f g of x, f over g of x. Really, really important that you realize we're going to get functions here and not numbers or values like we did in number 1. So let's go ahead and write our definitions. F plus g of x is equal to f of x plus g of x. That's equal to x squared minus 3x. I'm going to add that to 4x plus 5. No need for parentheses. So we just have x squared minus 3x plus 4x plus 5. I can combine those terms, x squared plus x plus 5. Whoops. And there we go. Okay. How about f minus g of x? That's f of x minus g of x. And that's equal to x squared minus 3x minus 4x plus 5. And these parentheses are important when we have the subtraction because we're going to distribute that negative. And we can combine these. We end up with x squared minus 7x minus 5. Okay. How about fg of x? That's defined as f of x times g of x, which is x squared minus 3x multiplied by 4x plus 5. You guessed it, we're going to multiply those two binomials together. So let's start with first. That's x squared times 4x. That's going to be 4x cubed. Now let's go ahead and multiply the outer, x squared times 5. That's nice, 5x squared. How about the inner terms? Negative 3x times 4x is a negative 12x. And our two last terms is a minus 15x. Looks like we can combine those. This might have been 12x squared minus 12x squared. There we go. And it looks like we can combine these middle two terms. So we end up with 4x cubed minus 7x squared minus 15x. Okay? Okay, now we have to talk about the domains. And so it's really, we still have f over g of x. Okay? Let's do that first. F over g of x is defined as f of x divided by g of x. And you're going to like these because we just write f of x in the numerator and g of x in the denominator. And that's all we have. Okay, now let's talk about the domains of each one of these combinations. And it's really important to talk about this. Now, in A and B and C, I want you to notice that the domain of f of x, that's a polynomial, and the domain of g of x, that means you can let x be anything you'd like, any real numbers, and it's okay. So when you combine functions that have a domain of all reals, each of them, then the domain of the combination is also all reals. Of each one of those. But what about D? We have to be careful with D because now we have a function in the denominator. And whenever you see that, that denominator cannot be equal to 0. So we like to set it equal to 0 to see what value of x makes it 0. so we will throw that value out. So we have to take negative 5/4 and remove it from the domain for the function in D. So this domain is going to be negative infinity all the way to negative 5/4, and we don't want to include it. And we're going to union or jump right over negative 5/4. Now we're on the other side of negative 5/4, going all the way to infinity. Okay. So combinations of functions, you just have to look at each function that you have combined, and then you have to take either you have to take the least restrictive or check for those denominators. Okay, let's look at number 3. If possible, use the given representations of functions f and g to evaluate. I'm going to tell you right now that I didn't give you much room because we have to find f plus g of 1, f minus g of 0, f g of negative 1, and f over g of negative 2 for every one of these. And that's just not a lot of room. So I'm going to try my best, and I'm going to write A along the sidelines here. So in A, I'm going to write f plus g of 1. That's equal to f of 1 plus g of 1. And now let's go to this graph. So f of 1, and f is this quadratic, okay, opening down. So f of 1 is going to be, when x is 1, when x is 1, y is 3. And on g, when x is 1, y is 1. That's what I was staring at. And we're going to get 4. Okay? Let's do the next one. F minus g of 0. So there's 1. F minus g of 0 is equal to f of 0 minus g of 0. And when x is 0, f is 4 and g is 0. So we also get 4. Okay? Let's go to fg of negative 1. Fg of negative 1 is equal to f of negative 1 multiplied by g of negative 1. Okay? I need to do some erasing on here. And so I'm going to x equal to negative 1. And f of negative 1 is 4. And g of negative 1 is 1. So, 3. Is that 3? 1, 2, 3. Yep. I thought that looked a little too high. And so 3 times 1 is 3. Okay, and we have one more for this graph. F over g of negative 2 is equal to f of negative 2 divided by g of negative 2. And let's erase these 2 points. I'm going to go to x equal to negative 2. There you go. And f is that quadratic, so that would be 0 over 2, and that's equal to 0. Well, we did a good job of fitting those in. Let's go to B. And I'll go ahead and change colors just to kind of help you find your way. And I think I'll work to the right over here. Okay, so this is going to be for part B. And I want f plus g of 1. And we know that that's f of 1 plus g of 1. And let's go look. F of 1 and g of 1. There they are, 1 and 6. So 1 plus 6 is 7. Okay, let's go do the next one. F minus g of 0 is f of 0 minus g of 0. And now let's get rid of that. Let's go to x equal to 0. Make sure you pick the right one. f of 0 is negative 1 minus 4. So we end up with a negative 5. Let's go to, I'm running out of room, but I think I'll make it. Fg of negative 1 is f of negative 1 times g of negative 1. Let me erase that. And we're going to negative 1. Most students like to find these values from tables. They do really well with it. So f of negative 1 is negative 3 multiplied by g of negative 1, which is 2, and we end up with a negative 6. So I have one more for this one, and I think I'm going to go on this left-hand side. So really all over the place, but hopefully you've organized your work better than I have. So that's f of negative 2 over g of negative 2. Again, let's give ourselves something to look at. So f of negative 2 is in the numerator and 0 is in the denominator, and we immediately write undefined. That does not exist. It's not defined there. Maybe I better move that. I'll just put something like that. Okay, let's take a look at this last one. Let me switch colors so that we can stay organized. And we're going to do all 4 of those combinations for this last problem. I'll start over here. F plus g of 1 is equal to f of 1 plus g of 1. Now, we're going to put 1 into f. So 3 times 1 is 3, plus 4 is 7. And g of 1 is the opposite of the absolute value of 1. Well, the absolute value of 1 is 1, so that's a negative 1. So that's going to be equal to 6. Okay. Let's go to f minus g of 0. We like to work with 0 because sometimes the answers are a little trivial. So f of 0, if I put 0 into there, it's 3 times 0 plus 4. So that's just equal to 4. Minus, and g of 0, the absolute value of 0 is 0, and the opposite of 0 is still 0. So that's equal to 4 minus 0, which is equal to 4. Okay? Here we go. Fg of negative 1 is equal to f of negative 1 times g of negative 1. And f of negative 1, look at that. F of negative 1 is 3 times negative 1 plus 4. That's a negative 3 plus 4, and that's just a 1. And then g of negative 1. Now, this one we need to be careful with. G of negative 1 is the opposite of the absolute value of negative 1. But remember, the absolute value of negative 1 is a 1. And then we're going to take the negative. So this is a negative 1. And that answer would be a negative 1. And finally, and we did end up with enough room, we have f over g of negative 2. And that's f of negative 2 over g of negative 2. And f of negative 2 is a negative 2. And g of negative 2 is a negative 2. So you end up with 1. And I'll leave that for you to check. And that concludes